Hello everyone, welcome to our March webinar. In this webinar, we will be covering new GMP Annex 1 Contamination Control Strategy document, and I will be giving you some examples along with viable and non-viable monitoring details together with this new Annex 1. First of all, let me introduce myself. My name is Hashim Solmaz, and I'm the General Manager of Lighthouse Worldwide Solutions EMEA Operations. I have different responsibilities in different organizations worldwide, including ISO TC209 as a subject matter expert and the founding chair of Turkish Contamination Control Society, and recently become a secretary of ICCS, International Confederation of Contamination Control Societies, and finally the faculty of IEST, Institute of Environmental Science and Technology, Contamination Control Institute. Before we start, I would like to ask you to send your questions in throughout this webinar platform. This GoToWebinar platform allows you to send your questions. If we have chance, then I will answer all these questions throughout the webinar. If I will not be able to answer your question during the webinar, I will definitely get back to you by your email since you already registered to this webinar. Okay, let's start. One of the main discussion about new GMP Annex 1 is a revision or a new like document. Main reason here is this document goes from 16 pages to 58 pages, and 99 new paragraphs already mentioned and added into the new version, which wasn't existing in 2009 edition. And 14 paragraphs were removed and 41 paragraphs remain same. So in general, most of the things related to this regulation, industry regulation, are changed. For contamination control strategy, we build an all-in-one approach, which also a good starting point for the operators and for the people who are preparing these contamination control strategy. So according to Annex 1, what is contamination control strategy? It defines it as contamination control strategy should be implemented across the facility in order to define all critical control points and assess the effectiveness of the controls, which is including design, procedural, technical, and organizational, and also monitoring. So we have 3 easy steps. We build these 3 easy steps for you so that we will be able to cover all the aspects of contamination control strategy as well as describe the details. Number 1, defining the contamination. Number 2 is controlling it. And number 3 is developing the strategy. As you can see, the document itself has all the answers that we need, contamination control strategy. So if you follow this 1, 2, 3 steps, then it will be easy for us to build our own contamination control strategy. I will also give you a couple of other examples for sure, but it's a nice point to start with. First, identify your contamination sources. So it requires a very deep knowledge of the process and also controlling them. Define your risk and prevent it. And the strategy, develop your own strategy by testing and monitoring these critical control points. So once you are done with these 3 easy steps, then you will be able to write down each and every identification, defining process, testing and monitoring with its results, so that you will have your own contamination control strategy document. Let's start with the first step, contamination identification. Types of contamination. First, let's define the types of contamination by airborne, viral particles, raw materials, endotoxin, pyrogens, whatsoever. So all types of contaminants should be defined first in order to define their sources. The source of contamination could be HVAC, personal, material, poor cleaning practices. So these are the weak points in your process where you can also introduce all these contamination by viable or non-viable. So these are the only sources that you can have the contamination in your clean room. What are the potential contamination areas? This could be starting from raw material all the way to the finished product by the formulation, sterile filtration, filling process, if you have a lyophilization process, then the capping, and all other attributes depending on your system design. So it also includes all the product and personal flow within the process. Number two, the step number two is the control we already defined. We said that define risk and prevent it. Materials and infrastructure is number one. You need to know the flow, material flow, design, maintenance, filtration, and equipment. This could be other attributes depending on your application, but in general, all the infrastructure elements has to be defined here based on this brainstorm. And then the personal, by the personal flow, gowning, handling, and their training, etc. So it has to be covered by this control step. And qualification, supplier qualification, personal qualification, equipment qualification, and process qualification, including all the validation documents related to these qualification steps, has to be a part of your contamination control strategy. And the simulations, your media field, gowning simulations for the personal, material handling simulations, all of them will give you an indication, a nice indication of control parameters. Number three will be our strategy. Now we already know the contamination sources and how to control them by critical control points. And now we have to develop our strategy. How? First, environmental monitoring. This could be the temperature, humidity, differential pressure, viable and non-viable particulate matters, and liquid particles. So you can include all kinds of environmental parameters into these monitoring section. Some of them are directly related to the clean room. Some of them are through the infrastructure, but all of them should be considered under this environmental monitoring. And personal monitoring, glove fingerprints, forearms, etc. So whatever required to monitor your personal within the sterile or non-sterile room, then you will have these measures in place. Testing, sterility testing, bioburden, filter integrity testing, lethality, or any sort of process-specific testing has to be included into this strategy as well. So what do we need to develop our contamination control strategy? First of all, process and technical knowledge. I think this is the foundation of our structure, which later on we will describe in PDA, New Technical Report 90. That's also given as the technical knowledge fundamentals. Because if you don't know your process well, then it's hard for you to define the ingress point for the contamination and also handling and monitoring it to get the right results from your process. If you don't have this information, if you don't know your process very well, and you don't have enough technical background of your processes, then it will be hard for you to define, measure, and control these parameters. Then define entire process workflow, including material and personal. All these workflow will tell you what are the weakest points that will introduce the contamination. This could be a viable or non-viable, which is a particulate matter or microbiological activity level. Then we need to define critical control points. This HACCP method here is the best approach for clean room contamination control mechanism in order to define critical control points. Then we need to define our risk and identify the risk level. After that, here we can have these HACCP, FMEA, or PHA, different and appropriate risk assessment tools has to be used on these processes. And after that, we need to minimize the risk of contamination and assess, control, and monitor individually, and consider collective effectiveness together. Because here, the critical point is, sometimes the critical point we described is not really helping us to find out what's going on in terms of contamination and how we will control it. That's why we have to focus on collective effectiveness of the process and how to execute our contamination control strategy. This contamination control strategy document should include a process and product overview and risk assessment tools that are being applied, all critical control points explained, limits, our alert and action limits should be defined, Risk priorities, predictive maintenance, risk reduction actions, and results of CAPA should be in place. We need to review our plan periodically. This could be changed from different pharmaceutical facilities, but in general, at least yearly basis, you have to revisit your requirements in terms of reviewing your plan and contamination control strategy document. And you need to plan an action for disaster recovery. The final will be monitoring and output review, including data trending. These data trendings will allow you to see before you reach into the alert and action level. It will give you wear and tear in your processes, any potential hazard for the coming period, and also making a necessary adjustments and predictive maintenance in your facility before it's too late. That's why trending your data is critical, even you are not reaching at a certain point of your alarm and action limits. So PDA come up with a new technical report, number 90. This is about the contamination control strategy development in pharmaceutical manufacturing technical report. This technical report provides guidance on how to establish an effective contamination control strategy for either a new or existing drug manufacturing facility or processes. That's a very good document because there are lots of examples on how to execute it. You can visit PDA website in order to buy this document. It's available online. And it also describes the elements of contamination control strategy, where I will also mention in my next slide. Process design, microbiological control and monitoring level, and facilities and utilities. After that, it starts with the production ingredients with the raw material, then the ambient air with environmental control, validation and monitoring parameters. Then the personnel section comes with the training and qualification of the personnel. Equipment design, validation and ongoing control comes next. And specific applications such as product containers and closures are also within another chapter of this document. One very important document which also adapted from the Sanofi processes to PDA Technical Report 90, which is figure 3.01. This also gives all the elements of the contamination control strategy. As you can see, we have the foundational elements of our structure, which are the scientific knowledge. This is rule number 1. We should have a scientific knowledge and the background of our processes, not limited with the product, not limited with infrastructure, not limited with daily operations. It has to cover all of these three. So you will be able to come up with a nice and steady information, this scientific information, so that it will allow you to build your contamination control strategy. The second level is about the quality risk management. This step is also in place in all these pharmaceutical companies, but it has to combine with this contamination control strategy in order to build and control important parameters. Then the personal awareness and quality culture is another fundamental element of your contamination control strategy, because operators, technical background knowledge from the engineering department or quality department inputs are quite critical in order to build and maintain this contamination control strategy documents. Then the next level comes with the contamination control parameter. As you can see here, the personal hygiene, training, and the gowning is number 1. Then the process design comes next. Vendor, material, consumables, and containers. Then the equipment design, cleaning and sanitization. Then facility and utility design, cleaning and sanitization comes next. Anything that can introduce a contamination to your clean room and to your process has to be identified at that level. Then validation of your controls. This also includes all the requalification processes and the mandatory life cycles, also the facility, utility, and equipment qualification documents as well. And on top, you'll be seeing monitoring of all controls. You already have these control points, but if you will not monitor it in a certain period of time, then you will not get any output which allows you to find the potential contamination control sources. That's why the monitoring on top is another critical step. And on top is the governance, defined oversight and escalation, which also the roof of our structure. Let's move into the template of the example template of the contamination control strategy. There are 8 important steps which you can easily follow. You can add more to this depending on your SOPs and depending on your application. But in general, these 8 easy steps will allow you to build your own contamination control strategy. Number 1 is the purpose. And this purpose part, you have to describe what is required, why you need this contamination control strategy document by saying, for example, to protect product quality from viable and non-viable particulate, pyrogens, endotoxin, and any sort of viral contamination. And number 2 is the background. You have to describe what you need, what you have learned from your contamination control strategy requirements, why we need it, and how we execute throughout this document. So this background also describes your process, your equipment, your personnel, and how you handle the process and how you end up with the product from raw material all the way to the final product. And scope description, where and how you achieve your contamination control targets. In the scope section, we want to describe our product, process, and facility as well. We need to write down all the control measures within this step. Let's say you have 15 different control parameters. You have to name them individually. So every single control parameters, this could be a microbiological control, personal control aspects, process, product, utilities, infrastructure. So all of them has to be mentioned in this scope part, because whatever you will describe in the scope, we will come up with this as a contamination control elements. So we will take them one by one and describe as a contamination control strategy parameters. And responsibility. Who is involved and what are their responsibilities? We have to describe one by one in this section. For example, if we have this quality people in this document, we will be describing their responsibility like to ensure that the policy remains current. And this contamination control strategy elements as a number 5 item. We need to address control parameters in the scope section items one by one. Like I described, if we have these 15 parameters described, then all of them has to be handled under these contamination control strategy elements. So by this way, we will be able to describe what are the measures, how we will control and how we monitor it, how we are using the output, and what will be the trend, what will be the limits for our structure, and how we are handling it. And glossary part is the relevant site definitions and all kind of abbreviations and reference documents. If you are using your SOPs as a reference or the site validation documents, this could be an equipment, utilities, or infrastructure. All the risk assessment tools that you use should be included in this reference document part, and other documents that are mentioned in this file. Keep in mind, we need to have a very short and lean contamination control strategy document. Let's say 20-30 pages, not more. Rest of it has to be described on these reference documents or annexures to this contamination control strategy document. For example, if you are describing your environmental monitoring system by non-viable particle monitoring, then you can describe in which locations you are collecting samples, how you are using it, what are your limits, and how you describe. Very short and lean description. But you can use the annexure in order to put non-viable monitoring system validation document, non-viable monitoring system risk assessment, pre and post risk assessment. All of them could be on your reference document part as an annexure. So for the authority, when they are auditing any pharmaceutical company, they'll be looking at the main section. They don't need to see each and every details as a reference within the document body, but if they need it, you can send them into these annexures so that they can get more information. But keep in mind, if you prepare this document from scratch, you will be starting with these annexures at the beginning carefully. But after that, during revisions, maybe the main body gets revised, but an exchange in place. In order to make sure, while revisiting your contamination control strategy, you have to double check your main body versus annexures and the reference documents that are up to date to your current application. If any SOP changes, it also changes in your contamination control strategy document. If any revalidation is in place, then you need to revisit your contamination control strategy and put it into this revision. By saying revision, in this section 8, your revision history should be in a table showing the revision number, date, and the summary of changes. If you add or remove anything from the main body, you have to mention it. And if you add or remove any annexures or reference documents to your contamination control strategy, it has to be described on this revision history. Most of the contamination control strategy documents will have several revisions once you start it, but in the long run, if process will remain same, you will have slightly changes within the document body and more changes on the annexure part. This is what we should expect from a living document infrastructure. Let's move into the particle monitoring and classification part of GMP Annex 1. First thing first, 5 micron still quite critical for pharmaceutical applications. I will tell you why during this presentation. First of all, this airborne particulate matter described in the table 1, maximum permitted particle concentration for classification. So this classification, including 5 micron particles, may be considered while indicated by the contamination control strategy or historical trends. By saying this, if you still believe that this limit is important for your operation, even if it's not specified in this document, you can still include these 5 microns in grade A and also grade B at rest conditions, and you can have your own limit. Reason I'm saying, we used to have this on classification purpose. We used to have 1 cubic meter of air to be sampled in grade A with 0.5 and 5 micron. Now the change is quite dramatic. We moved all the way to 0.5 micron, and the limit is based on ISO 14644-3. So 24 liters of air will be enough with 0.5 micron versus 0.5 and 5 micron with 1 cubic meter of air, which is in the past. So such a dramatic change, like 40 times less air without 5 micron, could create more contamination risk in your clean. That's why you can have your own contamination control strategy for non-viable contamination classification. And then you can describe, okay, I will start with 3,520 particles, grade A 0.5 micron, as well as 20 particles for 5 micron as a side information for me. And then limits will be this and this. And the limits will be defined in my contamination control strategy document as an addition to the GMP Annex 1, Table 1. And also you can say, for the first year, for example, year 2023, I will start by sampling 700 liters in each location to see the changes from 1,000 liter to the 700. If I'm still on the safe side of the operation, then I can lower this number to 600, 500, 400, whatsoever. But for me, my personal idea, moving from 1,000 liter all the way to 24 liters, if you are using 100 liter per minute instrument, 10 minutes to the 1 minute is a dramatic change for pharmaceutical production. This can create more issues by overseeing the contamination risk on your facility. That's why, as mentioned here in section A, you can also have your contamination control strategy in place by considering 5 micron, also by considering the minimum sample volume to be taken in each and every location. Instead of having a 1,000 to 24 liters dramatic change, you can lower this number within, let's say, 70%, 50%, 30% of the previous limit. So it will be a nice and steady move from one point to another. Each and every year, you can look at your trend. You can see you are still on the safe side. Then, okay, you can lower your volume. but this could be controlled by the contamination control strategy. It's still a risk point. For grade B, in operation limits are not predetermined. The manufacturer should establish in operation limits based on a risk assessment and routine data where applicable. If needed, if you are using grade B in operation conditions, then you can have your own limits defined on contamination control strategy document again. The main idea behind is to have this sterile manufacturing facilities for Annex 1 to be used for non-sterile application, which maybe in the future, the same Annex 1 would be used for the sterile and non-sterile production as well. So, Cleanroom classification for airborne particulate, all the classification, minimum number of locations and their position will be based on ISO 14644 Part 1. And for other locations, grade N and grade B respectively, additional sample locations should be considered if needed, depending on your application. Critical processing locations should be determined by documented risk assessment and knowledge of the process and operations to be performed in this area. So all the critical processing locations will be based on your background knowledge and the scientific information, as well as the risk assessment. And Cleanroom classification should be carried out both in at rest and in operation states. So during in operation, you can still use your current sampling locations for monitoring as a sampling locations for classification. And then you can add other locations depending on the size of your area. Airspeed is one of the most discussed issue. Will we measure this airspeed under the HEPA or at the working height, working position according to GMP? Take a look at it. We still have these limits, 0.36 and 0.54 meter per second at the working positions. But keep in mind, there is other sentence coming, unless otherwise scientifically justified in the contamination control strategy. What I recommend to anyone who is doing these airspeed measurement, first start with the air visualization studies. See what you do in general by sending the air out of your HEPA all the way to the production level with a unidirectional form. Sometimes, depending on the distance and the design, sometimes you achieve this goal with 0.45 meter per second at the working height, but sometimes it's 0.3 meter per second. So if you say, okay, 0.3 is not enough, it's out of classification, I have to increase my flow airspeed, then once you increase it, maybe your air visualization will show there will be a return air, which is a turbulent air at your working height. So the measure you take based on this number end up having failed by the production level and unidirectional flow to the turbulent airflow. That's why I recommend you to have your nice and steady unidirectional flow structured by seeing it through the air visualization studies. After that, define what is best at the working height and define what is best on your HEPA filter level. So within this too, because everything we do with the airflow is to provide a unidirectional flow from HEPA all the way to the production level. So instead of thinking your air velocity, prove what should be your air velocity at the working height in order to keep this unidirectional flow by measuring and also by air visualization studies. So it's quite critical because sometimes just to achieve this 0.45 meter per second air velocity, we are increasing the speed and creating more turbulent without unidirectional flow conditions. We are doing our production. That's even a worse case than having the less airflow by achieving the less air velocity at the working height, but still having a unidirectional flow. And another thing is the microbiology. This microbiology part is also described in this new Annex 1. And it says the microbiological contamination level should be determined as part of the Cleanroom classification. The number of sampling locations should be based on a documented risk assessment and the results obtained from the room classification, air visualization studies, and the knowledge of the process and operations to be performed in this area. So whenever you have this clean room classification locations for non-viral, you can also have them for your microbiological sampling points. Microbiological sampling points are always changing in your clean room because the dynamics can change. So once you have the specific locations, please make sure you are revisiting these locations and aligning them by the current clean room working structure. Sometimes even the equipment locations or the personal flow within the clean room changes, but your microbiological sampling location stays the same. So it's not really represent the risk-based approach of your process. The maximum limits for microbiological contamination during qualification for each grade are given in this table 2, which is in this slide. Qualification should be included both at rest and in operation states. So within the table, as you can see, in grade A, we shouldn't have any growth. Remember, it was less than 1. Now it defines as no growth, both for air sampling, active air sampling, settle plates, and contact plates. For grade B, we still have these 10, 5, and 5 limits, C and D respectively. So all of them are defined within this table 2 as a contamination, microbiological contamination levels. Cleanroom classification, the requalification periods. GMP Annex 1 says the requalification of cleanroom and clean air equipment should be carried out periodically following defined procedures. The requalification should include at a minimum the following, which is cleanroom classification, total particle concentration, non-viable, integrity test of final HEPA filters, airflow volume measurements, verification of air pressure difference between rooms, and air velocity test. So, you know, all of these tests are defined in ISO 14644-3 cleanroom test methods, and it describes how you will achieve these tests and how you will implement them. I can say for air velocity testing, profiling is important, but as we said before, also air visualization study is critical. So this could be included into your GMP Annex 1 cleanroom classification procedures. The maximum time interval for requalification on grade A and B is 6 months. C and D is for 12 months, once in every year. So cleanroom monitoring. You know, we used to have one single table for both cleanroom monitoring and cleanroom classification in the previous version of Annex 1. Now it changes into cleanroom classification, which we already covered, table 1, and there is another table, which is cleanroom monitoring. This is table number 5. This table comes with grade A, 0.5 and 5 micron limits. Reason here is, especially for grade A monitoring, 5 micron is a very good indication of early system failures, HVAC system failures indication, as well as poor cleaning practices, or wear and tear on our process, especially within the machine setup. So we will be able to monitor 0.5 and 5 micron with an online monitoring system, saying that we will have the same monitoring system in grade B. Number can be decreased. For example, while we have 4 or 5 particle counters within the filling line, you can have 1 or 2 particle counters within the room. This can be changed, but grade B should be also monitored. And this monitoring is not limited with any specific product. Even you are working with, for example, the dust-based, the powder filling lines, still you should have a grade A and grade B monitoring in place. But for example, specific applications like a powder filling, during operation, while filling, you already know that the particulate matter, which is coming from the material itself, the product itself, can cause an issue with the particle counter. So before the process, you can run the system next to the filling point, make sure that the air you supplied is clean enough, During production, you can turn it off, or you can hire this sampling point location a little bit higher than the needles, so that the dust is not coming, but still you are providing a clean supply air. And the final, after production, you will turn it on again or put it into the filling point nearby the filling height, so that you will be proving that before and after conditions are within the grade A conditions. And for grade B, room grade B, it should be in place no matter where you are manufacturing the powder or a regular sterile liquid feeding line. Still, you need to have the grade B monitoring system in place. Again, for grade D, in operation is not predetermined, but if you need to have a grade, if you need to define any limits for the grade D, you should describe it in your contamination control strategy document. So grade A monitoring should be full duration of critical processing, where when we said online monitoring, we are not saying 7/24. We're not expecting you to have this system up and running day and night. It should start before the production, as described with the GMP Annex 1, typically 20-30 minutes before your production, during production, and after your production until you have the final cleaning of your setup. And grade A area should be monitored continuously with 0.5 and 5 micron with a suitable sample flow rate, at least 28 liters per minute, which is 1 cubic meter of 1 feet cube air. The system should frequently correlate each individual sample results with alert level and action level, which means you don't have to wait until 1 cubic meter of air to be sampled for your classification, for your monitoring, to fit with the table 5, which I showed you here. You can have a certain level. For example, every minute, if you are using 1 cubic meter of air, 1 feet cube of air to be sampled in every minute, you can divide this number limits by 35, and you will have your limits like 100 per minute in grade A. And for 5 micron, keep in mind, we expect you to have no 5 microns at all in place during production while monitoring. Meter cube limits are given as 29. You cannot divide it to per minute samples, but what you can do, you can have 1 particles as a warning, 2 particles as an alarm action, and then you can monitor the entire structure. If it's a 1 peak, then it's okay, according to GMP. But if these peaks come in place at a certain time of your production, for example, while you are loading the stoppers, you have the peak in place, then it has to be investigated, because it could be an issue with the engineering design of your system or a poor practice of application. It has to be monitored. And alarm should be triggered if alert levels are exceeded. By saying this, we should have a visual and audio alarm within the place so that we will be warning the operators. We don't want operators to move all around the room and check the tables and display. We want them to hear the sound and see where it comes from, and they can describe this alarm point, whether it's already justified with the media field or if it's any deviation has to be noted to the system, the monitoring system software. And procedures should be defined, the action to be taken in response to alarm. Similar systems should be used in grade B, we said, although the frequency may be decreased. The selection of a monitoring system should take into account any risk presented and consider contaminants are present due to the process involved. Finally, the cleanroom monitoring, airborne particles. The size of monitoring systems samples taken using automated system will usually be a function of sample rate of the system use. It's not necessary for the sample volume to be the same, which is meter cube, as that used for former classification of clean rooms and clean air equipment. Monitoring sample volumes should be justified. So that's quite critical. Even this justification can be made in your contamination control strategy. If you describe your limits per minute, you have to describe how you pick them and how you monitor and how you take a necessary action if you are reaching to the alarm and action limits. So let's start with the Q&A section. We have 20 minutes more, and I will be answering your questions. Let me see if we have. Okay. Okay. We have one question here about to certify the clean room, do you mean that we can sample 1 cubic meter of air under new GMP Annex 1 standard? 1 CFM air, you mean, I think, cubic meter of air. So I'm not saying that we have to go with 1 cubic meter of air for classification, because GMP now says, okay, you have to follow ISO 14644-1 requirements. If you follow up with this requirement, then the sampling volume will be 24 liters, which is also enough for 1 minute of sampling with 100 liter per minute, 50 liter per minute, and 28.4 liter per minute instruments, the portable devices. But in fact, moving from 1 cubic meter of air, which is 1,000 liters of air, all the way to 24 liters is a huge dramatic change for pharma. Imagine your limits are going from 40 to 1. It's exactly the same thing because you are sampling 40 times less of air. So by this way, you are creating more risk to your operation. This is what I said. So you can control this number of volume to be sampled for classification throughout your contamination control strategy document. But in general, the expectation is not 1 cubic meter of air anymore. What is considered the working position? The working height. Okay, the FDA guidelines for sterility manufacturing indicates it's usually 1 foot away from the work site, but Annex will establish. Okay, good. The question is about the working height and the distance. There are two things. One, considered working position is where you have the aseptic manipulation directly. For example, if you are handling the vials, then the filling these vials is the point, the height of filling vials is the height of working height for us. But the risk distance at around is described, as you mentioned here, the FDA aseptic processing guideline described 1 foot away, 30 centimeters away from this area is our critical monitoring points. So we have to be within this 30 centimeters distance to our risk point in order to monitor. During classification of LAF, okay, just a second, I lost this question. The others are coming. During classification of LAF, should I work with 0.5 and 5? For classification, according to GMP, it's 0.5 only because it's a grade A. LAF is under grade A conditions. But if you want to align with ISO and GMP at the same time, I recommend you to take 0.5 and 1 micron because for ISO, you can classify this area with 0.5 and 1 micron as well. But keep in mind, you can have your 5 micron limits on your contamination control strategy document if you still believe that the 5 microns are quite critical for your operations within the LAF. So seeing these numbers is critical. How to perform risk assessment for monitoring plant, taking into consideration smoke test for grade B areas with non-unidirectional flow. For non-unidirectional flow, you don't need to have any smoke studies. I mean the air visualization studies, because we all know that this grade B area is a turbulent air. It's a non-unidirectional. So all you need to do is you can calculate your air change per hour in order to see the effectiveness of cleanliness and the system effectiveness of your air handling unit to return back in a certain time, which is recovery rate according to ISO 14644-3. This recovery rate gives you the protection index. You can set it up as a protection index, a certain number, and then you can perform this recovery rate testing instead of the smoke test. What is the position on air velocity continuous measurement in grade A? I don't recommend, personally, I don't recommend you to monitor air velocity at a certain distance to your HEPA. Reasons: for example, consider the huge area of filling line. You have several HEPA filters on top. Each and every HEPA filter has a different profiling, but you are sampling only one location, which is a good indication for the machine itself, whether the HEPA is active or not. It's a binary decision, open or closed HEPA systems. But for us, we don't, once you have this classification, sorry, the qualification of your clean room, the air profiling, you don't have to monitor it directly from one point all the time. Reason is because you will be measuring in one and only location. You cannot measure all the risk points. So instead, you can increase the frequency of profiling of your air velocity as well as your air unidirectional air profiling by seeing the air visualization studies. We had deviation during the audit, and we had to consider the smoke test for risk assessment. Okay, so according to the previous question, in grade B, there was a deviation for this pharmaceutical company. They were considering to have smoke tests for risk assessment for monitoring plan in grade B. They said we will be considering this issue again. Thank you. You're welcome. And refer to section 2.1. Raw materials and packaging materials should be tested on bioburden and endotoxin pyrogen. However, in my situation, the sterile product is eye drop. Can we justify endotoxin pyrogen test in excluded as the product is not parenteral product as per USP 1085 and USP 161? Still ongoing. Okay. Let me read out. Okay. The justification will be mentioned in the contamination control strategy. Unless you described it in your contamination control strategy, you can define how you measure, what are the risks first, you already define it, raw material risk. You need to test bioburden and endotoxin. Okay, how you will do it is based on your product. It's if the product is sensitive in terms of testing it, then you have to define your own method and describe it in the contamination control strategy document, as you already described. Okay, the customer wants to install its own light signal column in the monitoring system for each particle counter, referring to the fact that each monitoring point must have its warning and alarm. Is it correct or not? So sometimes for the monitoring, let's say within the machine you have 5 locations. Okay, each and every location, if there is an alarm, some customer says, okay, we want individual alarm tower to show us within this location. For example, within the turntable, filling location, and the capping, a separate alarm tower. This can be doable, but in general, the operator knows what's going on inside. And if they are interfering this production and there is an increase of a particle for a certain time, they already know it. And plus, most of the particle counters produced by Lighthouse has an alarm indication in their screen. So we are placing them underneath the machine to the surface of the machine. So if you see this alarm coming by the one alarm light, then this alarm light will tell you something happening in your sterile area. So you can look at which particle counter giving you the alarm. But 99%, the operator knows, because they already know which location they interfere, which location, what happened, what's changing in the situation, maybe the wire breakage, or maybe the fell down of an ampule. So they already know where they should expect this alarm. If they're not sure, they can still check the particle counters instead of adding separate alarm towers, because each and every alarm tower, by cleaning them, by maintaining them, is also another thing for the sterile room, production room. Instead, having one alarm light is adequate for us. This is how we design most of our systems. and then getting the alarm from the alarm tower and checking the locations by seeing the particle counter. It's also enough. How to issue the contamination control strategy with several buildings and each building several manufacturing lines separate? Yes, exactly. You have to have a separate, because when you have the scope of a definition, you're also defining the line products that are manufactured within the line and the inputs for contamination, starting from raw material of this product all the way to the end. So you cannot have one contamination control strategy fits all lines and different factories. That's why it has to be separate. Of course, there are many similarities because the process goes through the same operations, but still there are definitions, differentiations from one to another, and it has to be a separate one. Which grade we aspected for LAF in C grade, such as sampling area A or B? It's depending on your application, because the surrounding area of grade A could be grade C or grade B, because if it's a terminal sterilized product, then you can have this grade C environment, or if it's not a pharma application, you still have the grade C and grade C ambient and grade A LAF or by safety cabinet, depending on your application and the risk. If the product comes throughout the process, room has to be in grade B because it's interfering with your grade A environment. But if it's not interfering, then you can have these grade C environments as well. Okay, one more questions. Should recovery tests be performed for non-sterile areas such as final blend room and corridor? Good question. Recovery test is for most of the clean room areas, not limited with sterile or non-sterile, because this recovery will tell you whether you have the highest risk or not. It's also showing you the cleaning efficiency of your HVAC system. So this HVAC system, by having a certain air change per hour rates, recovery will be lower. So depending on the application, sterile or non-sterile, you have to implement this recovery testing to these areas. Okay, we have enough time. Let me see if we have more questions coming in from different audience. If I didn't catch any. There's one question with the depyronization tunnels with the under HEPA. The question is, should we limit ourselves with 0.36 to 0.54 meter per second? In general, yes. This is a very small and very narrow area. So if you catch within this limit, since this system has a very high air velocity measurement and the cleaning efficiency, then you can have within between these numbers. Distance is very short. That's why it's in any case it will be a turbulent, but the collective cleaning efficiency is important in this aspect. That's why using 0.36 to 54 is important, but you can still adjust it based on differential pressure as well as the cleaning efficiency. I'm looking for other questions coming in from different audience. How can we evaluate contamination control strategy document? Periodically, is it acceptable for every year or more? Depending on your application, at least once in every year, you have to make a periodic review of your contamination control strategy document. But if things are changing in the production, in the process, in the equipment, or the cleaning design, this has to be revisited because these are all the inputs to your contamination control strategy. Remember the section scope. If anything changes in the scope section, you have to revisit in order to justify your contamination control strategy. Okay. That's all for now. Thank you very much for your time and hope to see you on our next webinar next month. Thank you.